All right. So again, it's week 12. I just gave a little 20-minute deal on where I have been with my own permitting issues. I'll just show you the rest of these drawings. They're not overly fancy, but I put in a here's my budget. I just took it from Microsoft Excel, slapped it in there. Cat 6 cable. I had to buy 1,000 feet of it. Number 12 AWAG, so American wire gauge, 50,000 feet of that at $52. This is 648 of Schedule 40, so I had to do 2 separate runs, 1.25 inches. That was the part number. These are the sweeps I was telling you about. So 45-degree, male on one end, female on the other end. This was a coupler. I can't remember what that is. These are the 4 caps so that water doesn't get in. There's the PVC cement. This is the green line. So it's just twine, so you can pull the wire through. And I asked him, I said, can you put the twine in there for me? He's like, sorry, I don't have enough time to put the twine in. I'm like, oh, how am I going to pull? He goes, well, you're gonna unspool the twine. You're going to put a cotton ball on the end of it and suck it through with a vacuum. Because one of the first, there's a couple rules in engineering, and one is that liquids don't flow downhill, and the other one is you can't push a rope. So here we go. I'm gonna try to push that rope through. But Andrew McChain is also a graduate of the program. He's got his own company, Battery Doctors, and he's done some of the work for me. I just did a little drawing showing that I've got to have the Ethernet and the power at least 12 inches apart from each other, so I don't get crosstalk on that noise.
The depth is arbitrary?
Yeah, I didn't, because they were digging for sprinklers. And the sprinklers, I think they've got it, well, it's tough to get below the frost line in Montana, because I think you got to be like 4 feet down there or something like that. So, and that's why you see these sprinkler systems getting drained in the fall. And I didn't want to tell them I've got to be some certain depth, but electrical code in Montana is pretty lax. Even in my own backyard, I've seen wires buried without any conduit. Just bare wires. I think that's where a lot of wires are just in the ground like that around here.
Oh, yeah.
So
People just do it themselves
Stick it.
now.
well, anyway, I think as long as it's underground, it's got a conduit around it, and Northwestern Energy requires that you call 811 and dig before you go. So now we've got drawings in place. They kept a record of where they are. So those things are now in place and in the ground. So there's my own little project. And, maybe down the road we put some PV on that men's room, supplement it, augment it.
You guys thought about like a generator just running in the river?
Yeah, I don't know if they've redone Brenn's Wave yet, but we did a little micro hydro as a surface project a couple years ago. But yeah, it'd be cool to put some micro hydro in the wave too, for sure. Okay, let's look at what the what the course website has to say about the permitting process. I'll just kind of highlight some of the things that this individual has to share. So Bill Brooks is also a professional engineer, small scale. July 2012. There's your legal right up front. Just looking at something else like that. It's it's necessary. I'm working with a lot of other guys here in Montana who are trying to do some clean coal work, and you got to have the legal agreement up front. You have to know what everyone's responsible for financially, liability. So it's just part of it. Got to have a lawyer. Sorry. Otherwise, it's just kind of he said, she said at the end. Local jurisdictions, awarding building permits. And so this 10 to 15 kilowatt, you're not going to find a residential system any bigger than that. So that's where we are. Absorb engineering review costs. I've done a lot of professional engineering stamping for Bobo here in town, and I'll just go there for an hour or two, charge him a couple $100, and he's good. Much bigger project, much more expensive engineering fees typically. And in fact, well, since I mentioned that, let me just show you some of the work that I've done for Bobo here in town. Oh, this one's too. This is one where I kind of went a little overboard and started doing payback analysis for thermal. He's like, wait, I didn't. No, we didn't. We weren't doing that. Okay, so here's the permit itself. This particular house had a lot of thermal issues too, but there it is, expedited permit. So only in needing basic review, and these were not very complex. And again, 50 to 75% of all residential systems will comply. Everything we've done so far has, in fact, fallen under that. The drawings don't have to be overly complex. You don't necessarily have to have a CAD drawing. And here it is. This is just Bobo's drawings. I signed off on them as a professional engineer. He showed each of the attachment points. 2.5 kilowatts. That's your typical PV installation system. We get 4.4 hours of sunlight. So let's just do that calculation really quick. So 2.5 kilowatts, and that's what it's going to actually generate. And that's kilowatts times 4.4 hours equals. So you're gonna make on average 11 kilowatt hours of electricity per day with the system. You divide that by 24 equals times 1,000 equals. So what you're looking at there is an average. So we've done the load analysis. What you're looking at is an average of 450 watts for the house, which is enough if you're being careful. You're not going to run your plasma TV and your electric hot tub and 3 freezers and fridges, but 450 watts, that's a reasonable amount of electricity for a family of 2, maybe 3, or 4 if you've got the LED bulbs and all that. And that's about where this family is. So you can go back and look. So there's your 2.5 kilowatt system. The snap and rack system itself has already been reviewed by their engineers. It's not like he's up there, pulling aluminum scrap out of the dumpster at Home Resource to put this thing on there. It's already, it's already a UL approved system. I wanted to make sure that was the case too, so it doesn't violate my own engineering code of ethics. The drawings are there. I was able to see them, prior to installation. They've got nice detailed drawings as well. So I included all of this in my report. And there you see another professional engineer has signed off on the validity of the design of these systems. Okay. And so it's pretty simple, fairly straightforward. Permitted roof structure, you're gonna check yes, and I'll go in as a structural engineer and actually climb up in the attic and make sure that the rafters aren't rotten, or that they're not like 4 feet on center and instead of 2 feet on center, and he's gonna miss them, or there's some other structural issue with the roof. But he's actually gonna penetrate the shingles. Single covering, flashing and caulk on every single one of those penetrations I just showed you. He's got a 24-inch gap, and that's why he had to check no on that particular one. The rafters were 24 inches on center instead. Here's the load. 240 pounds. 240 pounds is just the static load. He's got 16 attachment points total, so that's 15 pounds per system, and that's static. That's just sort of sitting there under gravity. It also means that for some reason the thing got flipped upside down. Each fastener would only have to hold 15 pounds of force. He can allow for up to 32 inches of spacing, so the 24 on center is not an issue. Total surface area, he's got that in square feet, which is only 3 pounds per square foot on the roof, pretty minimal. So this is also, and I did not see his electrical diagram, but that's the this is so you don't get excessive voltage on the system. Only 4 strings per inverter.
They're in parallel?
Yeah, composed of 4 strings. Right, 4 parallel strings. So, and it was well less than that. I think it was only 2. Total inverter capacity, well under 13 kilowatts. And this refers to a particular bit of code, and that's going to be in NFPA 70. And we can, I have not clicked out on that site, but this is another place to make sure that the electrical diagrams comply with that. Oh, yeah. And so in this particular house, let me show you. He had two separate installations. That's why he had 2 separate permits. Oops. See if I can find that. So he had one system, and you can see it's right over here on Mount Street. So one system sits on this side, which is the east elevation, so he's getting a little bit of eastern sunlight, and I think he had to do a little bit of tree trimming to get that in place. Here's the west elevation, so looking from the opposite side. So this direction to the right of where I'm pointing is south. And so this is where you use those snap and rack, the racking system sitting at, I think it was right around 45 degrees. And we've gone through the math on optimizing that. Okay, so that's why you need two separate permits, if you will, because there were two separate arrays. Yeah. So slightly different math on that guy, but slightly different pounds per square foot. So anyway, I ended up signing off on that, and that was just kind of a cool little job. Bobo, he might be a good candidate to help me out with this Brennan's Wave project, because he is a licensed master electrician and I think would be willing to get paid even though he doesn't own the whole system. So I'm glad I went over that, because now I think I might have answered my own question. Yeah. Okay. Here's another thing that I've come across recently in my own practice. As a licensed PE, my PE license is valid in all 50 states with the exception of California and Alaska. That might be the case too for some of these other certifying groups like NABCEP that you run into. I think NABCEP has reciprocity with Alaska. I'm not 100% sure. The reason the National Society of Professional Engineering does not have reciprocity with California or Alaska, California has earthquakes and it gets really cold in Alaska. So temperature effects become a whole different ball game in Alaska. So that's why, separate codes. And there's the NEC. If you take the practicum this summer, we're going to have a few questions also on the NEC. And it can get weird. It can get crazy. You can go way down the rabbit hole and never come out. But
That's what I do every day.
that is the advantage though of becoming a licensed master electrician. Once you know the trade, you kind of know what works, and it becomes a little bit cookie cutter. Works for you in that case. That's why sometimes it can sort of work against the renewable energy systems guy who's trying to get creative. There's not typically a whole lot of room for creativity sometimes in this thing. That's why you have to make the two work.
Is a master electrician's degree offered here?
No, flat and the master electricians. It's an apprentice and a journeyman system. You don't just go to school and get it.
Mm-hmm.
We do offer. We didn't offer it this spring. I offered it last spring. We do offer. That's the challenge of Montana education. There's just not that many people here in the state. But I was able to offer this electrician's helper certificate to 3 students. In fact, we did some work on Brennan's Way. We did some work at Montag. We even did some work at my house. It was kind of ugly, but it's student work. Kind of fudged our way through it. You got to start somewhere. But we do offer a certificate of technical skills in this thing we call the electrician's helper, and we offer it through these guys. And I can't remember what their acronym stands for. National Contractors, something, etc. And so I'm actually NCCR certified to teach electricity 1 and 2. It's kind of fun. We got some stuff done. And this is something also that's nationally recognized. So if you've got a interest in this, we could fire that course up again in the spring and see what we can do with it. But so I went through the core curriculum with the students and also the electrical part of it. But it's a stepping stone towards the IBEW. All right. IEEE is the Institute of Electrical and Electronic Engineering. They also set the standards for the codes. And there you go. He's also helping write new codes for integrating between solar and electric. And he happens to be a registered PE in North and South Carolina. I don't know how old the man is, but it's probably taken him a while to get there. But he's one of these guys that's sort of a unifying force between the old school electrical and new things coming online. So if you like, I would say go ahead and contact these guys, see if what they've got to offer is something that we can work with. So looks like there were several co-authors on this thing that he's attributing it to. Let's just dig into some of the some of the other things. We already talked about 10 to 15. There's your engineered mounting system we talked about with the snap and rack. There's your minimum on pounds per square foot. There's your 13. So all these numbers we're seeing were straight off that permit that we just worked with. Let's look at this. I'm just going to read out loud. Problems with the existing process of permitting PV systems. Given the distance of permitting systems across the U.S. and the significant variations in experience relating to system inspection in various jurisdictions, it becomes apparent why permitting issues have been cited as a barrier to the widespread installation of PV systems. Let's just see what he has to say. And so this is a big one, lack of consistency. Lack of consistency among jurisdictions. Yeah, this is what happened to me. When I started putting in the thermal stuff, BD's or Bobo's just take it out, because it's just going to confound the issue. And so it's really almost the less you say, the better. And at some point, it just comes down to me as a professional saying the roof's not going to blow off, it's not going to leak, the panels aren't going to break, et cetera, et cetera. You sort of and you've worked with somebody in the past, kind of like you try to get in, become an apprentice with this guy, but it doesn't always work out. So you can kind of see why these monopolies and systems might form, for better or worse, just out of consistency. IREC, we've been in contact with them. We were trying to work with them to become an IREC certified institution. It didn't work out because the DOL, Department of Labor, kind of pulled our funding halfway through our grant, and because IREC was really trying to jump the moon and become IREC ANSI. So ANSI is the American National Standards Institute. they're way pickier, way more stringent. And IREC could not afford to be endorsed by ANSI. So IREC is now a standalone accrediting agency. And I don't know, IREC and IBEW kind of go toe-to-toe on some of these things. Maybe they do, maybe they just need to work together better. New Jersey, I was just on the phone with Charles today, and he said, California is an innovator in a lot of things, and New Jersey, not so much. You still can't pump your own gas in New Jersey. I don't know if you've been, but it's illegal to pump your own gasoline.
Is there an attendant?
Yeah.
Like Oregon too, Oregon's the same way.
Yeah.
I've
Can't
never
pump your own
been
gas.
somewhere like that.
Yeah,
Yeah, you try to get out and pump your own
Yeah.
gas, they just run at you, like, no! Yeah.
yeah,
In your car?
yeah, 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 yeah. So,
Could you imagine, let me kind of, just pull it,
well,
let me up, let me go.
I even heard recently, we were there in Chicago, and my brother-in-law, the one with the IT farm, I said he was kind of getting some pressure from Google, Midwest. Said when they were building the Hancock Tower in Chicago, the IBEW banned the use of screw guns. They would not allow their installers to use electric screw guns. They had to all use manual screwdrivers. Well, takes longer, and they're on the hourly clock, and so they're
I think that's like a subtle play, because they didn't want.
I don't know. I mean, there's some danger in it too, but I would just kind of think that the repetitive injury of using your hand to screw something in would be like, whoa, man. So anyway, there's all these funny little things that come up. It's kind of funny that the Sierra Club gets involved, but they do. So what? Department of Energy guidelines. Yeah. And when he's saying unifying, he means national unity. But one of the great things about this country is that we've got a balance of power between states and the Fed. Just learned very recently, I've been traveling a little bit with the former governor of Wyoming, big coal economy, and he said the pressure, there's a lot of pressure coming out of the Fed right now to shut down coal. But of course there's a lot of pressure coming back from the states to keep it open, because that's where the money comes from, right? So you kind of see where the states would like to expedite, move forward, bring in clean tech, but if the Fed is trying to shut down clean tech for whatever reason, there's a problem. The other thing operates in reverse. The Fed's trying to bring in the clean tech, and the states might want to push back. In the case where Montana and Wyoming just push back against the clean power plan. So, and here we are in the middle. What?
There's a coal mine in Wyoming that went bankrupt. Just like in a very short time.
Peabody?
Is that it?
Could be.
That went down to 5% of what their production was, or the demand.
Yeah.
I don't really know.
Yeah, I don't know either, and I don't know why or if these companies are declaring bankruptcy. I'm going to stop the recording 1 second, then I'm going to get back on because I don't want to go too long with a single recording. But I think I have a little bit of an explanation for that. It's kind of subtle.